Hi everyone. Today I'm presenting our project, the Incident Response Assistant for Campus Housing, or ARIA. This is a cloud-based system designed to help campus housing staff quickly access the correct policies during real-time incidents. What the application is. So, ARIA is a cloud-based application that allows housing staff to ask questions during incidents and get answers grounded in official policy documents. So instead of searching through PDFs manually, a staff member can just type a question into chat interface. The system then retrieves relevant policies, content, and generate a response based on only those documents. This makes the answer more reliable and easier to trust. So, the problem we're addressing is that housing staff often need to respond quickly to situations like fire alarms, self harm reports, or policy violations. But finding the correct policy during a live incident can be slow and error prone. Our goal was to build a system that gives fast, accurate answers based strictly on approved housing policies. To achieve this, we used a technique called Retrieval Augmented Generation, or RAG. Instead of generating answers freely, the system first retrieves relevant policy text, then generates an answer grounded in that content. Why RAG? So, a key design decision was using RAG instead of a normal chatbot. General chatbot can hallucinate or give answers that aren't based on actual policy, which is risky in this context. With RAG, the system first retrieves relevant policy chunks and only generates answers using that retrieved context. This improved transparency because the answers are tied to real documents and reduce the risk of incorrect or unsupported responses. So overall, it makes the system much more reliable for real-world users. Our architecture. So our system is built around two connected pipelines: document ingestions and question answering. The ingestion pipeline builds the knowledge base. Policy PDFs are uploaded, stored in Google Cloud Storage, then processed through event-driven cloud functions. The system extracts text, splits it into chunks, and then generates embeddings using Vertex AI. These embeddings are stored and used for semantic search. The second pipeline handles question answering. When a user asks a question, the front end sends a request to the answer service. The service calls a retrieval service running on Cloud Run, which finds the most relevant policy chunks. Those chunks are then passed to a language model, in our case Gemini, which generates a ground response. The answer is streamed back to the front end in real time. So overall, ingestion builds the knowledge base, and the query pipeline uses it to answer question. Recently, we also added Firebase authentication to secure the admin upload flow, so only authorized users can upload policy documents and the backend verify requests using JWT tokens.
All right, thank you, Triet. So my name is Tariq Alamin. I'll be explaining the rest of the slides. So now we have implementation details. So in the implementation details, I'll talk about our CI/CD pipeline, simply how our test cases are automated and how our deployment also is automated. So when pushing or creating a pull request, that triggers the CI/CD pipeline. So when the CI/CD pipeline, it creates a virtual machine, an Ubuntu machine. It gets all the code from GitHub. It sets up Python, install all the necessary dependencies to run our application. It also from there it runs all the unit test cases. Then it deploys to the front end. So it sets up Node.js environment, install the dependencies for the front end, and then deploys to Firebase hosting. This is where our web app is hosted. From there, it deploys the backend. So it starts by configuring Google CLI for deployment, and from there it deploys the different Google Cloud functions. So it deploys ingest document first, and then deploys embedded chunk function. From there, it deploys retrieval service, and then it deploys the answer function. All right, in this slide, I'll kind of do a quick demonstration of our application's workflow end to end. So, so in the left, we can see the chat interface shows that the system can respond to realistic policies. It can respond with grounded policies. And then on the top right, we can see that the admin page shows a new PDF document can be uploaded into the system. And then at the bottom right, uh, is the Google Cloud Storage screenshot, which shows evidence that the ingestion pipeline is working because we can see process chunks and generated embeddings after upload. Together, all of these screenshots kind of demonstrates that the system is not just designed on paper. It can ingest new documents, build a knowledge base, and then use the knowledge to answer the questions. All right. So in this slide, we are showing that the system can handle increased load without us manually changing the infrastructure. To test that, we used Locust to simulate more users send their requests to the retrieval service, which is the service that is responsible for bringing back or answering the user by sending the right policy. So and at the same time, we mentioned Cloud Run. We monitored Cloud Run instances count and request behavior. So what we found was at a low level, at a low load level, like one user and five user test, the system stayed on a single Cloud Run instance because one instance was enough to handle the traffic. But when we increased the load to 10 users, Cloud Run automatically scaled the retrieval service from one instance to two instances. That's important because it shows that the service can respond holistically when when demand goes up, instead of us having to kind of pre-revision extra services. We also recorded 125 requests during the 10 user run. So this was not just like a single spike. It was enough traffic to actually observe scaling behavior in practice. At the same time, even though that the system scaled up under load, the cost stayed low. Where our observed cost over the measured period was only 76 cents, and forecast monthly total was $2.11. So the main takeaway from this slide is that the retrieval service or the retrieval layer is both scalable and cost efficient under normal usage. It can stay small and inexpensive, but when traffic increases, Cloud Run can automatically add capacity. That makes the architecture a good fit for a campus housing tool, where demand is probably bursty rather than constant. All right, into our last slide to wrap up. We built a working cloud-based incident response system for campus housing. The system is able to take approved policy document, process them into searchable knowledge base, and then use that information to ask incident-related questions through a chat interface. What we are most happy with is that the core workflow end to end. We showed that the document can be uploaded automatically ingested, turned into chunks and embeddings, and then used to generate grounded response. We also showed that the retrieval itself is fast. The retrieval service itself is fast, and that retrieval service can scale under higher load using Cloud Run auto scaling. At the same time, this is still a prototype. There are clear ways we can improve. Some of the biggest next step would be improving the retrieval service accuracy, making citations stronger and more reliable, reducing the slower end-to-end response time, and polishing both the admin interface and the user experience. So overall, our project demonstrates that this is a practical direction for building an internal policy assistant tool for housing staff. With more testing, better retrieval quality, and a larger policy data sets, we think it could be extended into a much reliable production-ready system.